This is question number 3 from the SACE Stage 2 Physics Course Companion from subtopic 3.3, Structure of the Atom. Here we have a simple electron energy level diagram, so just n equals 1 through to n equals 3. First we need to explain what is meant by fluorescence. So instead of trying to write this out, I'm going to type it because my handwriting gets a little messy. So here fluorescence means that in this case it's one type of fluorescence is when an electron is raised 2 or more electron energy levels, then it reverts back to its original state via the 2 or more levels as it transitions downwards. If it does this, then multiple photons are emitted. This is what we mean by fluorescence here. So let's write that out with a bit more detail. So when start off over here. So our description of fluorescence is when a photon is incident upon an electron and causes it to transition upwards over 2 or more electron energy levels. It may transition downwards via 2 or more electron energy levels. And if it does this, 2 or more photons are emitted. So when this occurs, 2 or more photons are emitted. This whole process is what we call fluorescence. So it is one type of fluorescence, not the only type, but for the purpose of the Stage 2 course, then that's the only type that we're really concerned with. So that's just an explanation. Now we have to actually work out something. So for part B, this is all part A. For part B, an electron is raised to the n equals 3 level and it fluoresces. So we need to calculate the energy and frequency of those photons. So just to recap what we've just done, so if we've got 3 levels here, so n equals 1, n equals 2, n equals 3, our electron has transitioned up to here, then it's going to revert back to n equals 1 via this level and this level. Each time emitting a photon, what we need to do is calculate the energy and frequency of each of those photons. So let's do the n equals 3 to n equals 2 transition first. So here, same process as we've done for all the other questions. We need to first work out the energy of the photon, so that'll be equal to the difference in energy levels. So 4.56 take 1.23. So 4.56 take 1.23, which equals 3.33 electron volts. We need to convert this to joules. So this will be equal to the 3.33 multiplied by the charge of an electron, which if we substitute into our calculator, we get 5.33 times 10 to the power of minus 19 joules. Now we just have to work out the frequency. That's easy enough. We have E equals HF, therefore F equals E on H, so 5.33 times 10 to the power of minus 19, all over Planck's constant, 6.63 times 10 to the power of minus 34. Substituting into our calculator gives us 8.04 times 10 to the power of 14 Hertz. Similarly, from n equals 2 to n equals 1, it's the same process. So here the energy will be equal to the difference in energy. So 12.62 take 4.56. So 12.62 take 4.56, which equals 8.06 electron volts, which we convert to joules by multiplying by the charge of an electron again, which happens to equal 1.29 times 10 to the power of minus 18 joules. And same as before, equals HF, F equals E on H, therefore 1.29 times 10 to the power of minus 18 over Planck's constant, 6.63 times 10 to the power of minus 34. Substituting into our calculator gives 1.95 times 10 to the power of 15 Hertz. And that's it. So this question wasn't too bad. This explanation took a little while, mainly because of the typing, but the rest of these calculations are actually pretty easy, and there's no tricky rearranging or anything like that. The only thing you really need to remember is to convert the electron volts to joules. Otherwise, it's fairly simple.